So this unit, we got a couple things going on. And like I told some of your parents at parent-teacher conferences, the stuff that we're doing right now is sort of preparing us for the algebra. Because one of the big things, and I've said this to you guys before, is we want to really develop our algebra skills in grade 9, because we're going to be using them a lot in grade 10, 11, and 12. But before that, we got to know some basic numbers, like with fractions and with positive, negative numbers, which we did in Unit 1 and Unit 2. And then we're also going to do some exponents. That's the next unit. But in this one, we're going to do square roots, and then we're going to do a little sort of go off and do a little geometry for a bit. Okay. So hopefully you're given, or you have some idea of what a square root is, okay, and how to take the square root of certain numbers. But square root comes from, let's say we want to find the area of a square. So we know, want to find the area of a square, and we know that one side is 5. Well, the area of a square is base times height, or length times width, or 5 times itself. Okay? But whenever you multiply some number by itself, that's called squaring the number. In this case, I would square the side length to get an area of 25. So you guys have done squaring, probably squaring with positive numbers. Those are not the only kind of numbers that we can square. We can square decimals, we can square fractions, we can square negative numbers. Okay. So for example, let's say the side length of an area of a square, or side length of a square is half a centimeter. Well, we find the area by doing 1/2 squared, which means (1/2) times 1/2. And you guys should be comfortable with multiplying fractions like this now to get 1/4. And we're finding the area of a square, so we need units. What would the units be? Centimeters squared. So if we take an answer, or so if we take a number and square it, we get another number. What about if we want to go from that number back? We want to do the reverse of squaring. Well, the reverse, or what we call the inverse, is the square root. And that's the little symbol that looks like that. So when we square a number, we're taking the number times itself to get the answer. But when we square root a number, we're going backwards and we're figuring out, well, what number times itself gives me the answer? So for example, if I said the square root of 16, you're saying to yourself, okay, what number multiplied by itself gives me 16? 4. And you should be familiar with how to take square roots of numbers like 4 and 9 and 16 and 25, etc. Okay, what we call perfect squares, which I'll get to a little bit later on. And the name of this little symbol is called Copernicus. Because square root is just one type of radical. Okay. So I'll talk about it in a second. So, like I said, you guys should be familiar with how to find the square roots of certain whole numbers. Probably other numbers by using a calculator. Okay, I'm sure you're familiar with that as well, and we're going to review Pythagoras a little bit later on. But what about if we're finding the square root of a fraction? So I'm told that the area of a square is 49 over 25. I want to figure out what's one of the side lengths. Well, to figure out the side length, I'm given the area of 49 over 25, and I got to figure out what side or what number times itself gives me 49 over 25. In other words, we square root a fraction 49 over 25. Now, this is something that may be new to you, that you haven't seen square roots of fractions. Well, they're pretty easy to do. To find the square root of 49 over 25, just think of it this way. Take the square root of the top number over the square root of the bottom. That's it. So the square root of 49? No. No. 7 over the square root of 25. So our answer would be 7 over 5. Okay. So that's something new you'll probably see is squaring fractions and square rooting fractions. Yeah. You'll never have to reduce. Yeah. Unless the original fraction you have to reduce before square rooting. Okay. But yeah, that's a good question. We're going to talk a little bit about that in a second. Okay. So what if I said this? Just give you as another example. What's the square root of 1 over 9? One over 3, right? Because it's just take the square root of 1 over the square root of 9, which gives you 1 over 3. So you see that square and square rooting, they are inverse operations. One undoes the other. So if I take a number and square it, to get back to the original number, I square root after I square. And like I said, a square root is just one type of what we call radical. Because there are different types of radicals. Like if I said, okay, square root of 9 is 3, right? Just to find the square root of 9, you say, okay, what times itself gives me 9? And that's 3. What do you think this might be? Do you take a guess? I think actually, whenever we write square root, technically we should be writing a little 2 there.
So wouldn't it mean like you're multiplying it with 9?
Yes. So what number times itself again gives you 8? What number times itself again gives you 8? It can't be a very big number. 2. And we call this cube roots. So for square roots, we're saying what number times itself. For cube roots, we're saying what number times itself times itself. I mean, I could keep going. 4th root of 16. 4 times 4 times 4 times 4, that's going to get you a really big number. It's got to be smaller, right? What number times itself times itself times itself gives you 16? 2. Again. And you could keep going. What do you think that one would be? Think of the pattern I was saying. So 2 times 2 times 2, 100 times, it's going to be 1. No, it's going to be too big, right? It's on the right track. It's got to be a low number.
1.
Yeah, wouldn't it be 1? Because what number times itself, 100 times gives you an answer of 1. Well, you can multiply 1 by 1 as many times as you want. The answer is still 1. So yes, the answer here would be 1. But we're going to worry more about these next year. I just thought I'd show you what they look like just to start. But we're not going to focus on these this year. Okay, we're going to focus just on square roots. So a number that if we take its square root, we get a whole number answer, or we get a decimal, or we get a fraction. Okay? Has a certain name. Or we can define it as a number that can be written as some other number times itself. Has a certain name. Can you think of a number that you can take another number times itself and get that number? I know it sounds a little confusing. Think of a number, and then think if there's some other number times itself that gets you that. So like if I said 2, is there something times itself that gives you 2? What times what? 1 times 1 is 1. What number times itself gives you 2? Yeah, you can't think of it because it's actually a very long number. It's a long decimal number. Can you think of a number? Yeah. What's that?
6.
Yes.
36.
36. Why?
Because 6 times 6 is 26.
Perfect. Now maybe you get the idea. Can you think of another one?
3 times 3 is 4.
So 4 is the number. 9. Not a perfect square. I'm sorry. Yeah, go ahead. 81. Those numbers that can be written as some other number times itself is called a perfect square. So the whole number perfect squares, well, the lowest whole number perfect square is 0 because it can be written as 0 times 0. What's the next one? The answer to 1 times 1. What's the next one? The answer to 2 times 2. And then 9, and then 16, 25, 36. What would be the next one? 49, 7 times 7. What would be the next one? 64. 2 more.
81.
1 more. 10 times 10.
100.
100. And then it would keep going. But those are some of the ones you should be familiar with. Okay? Okay, let's do a couple of examples. Let's sort of talk about square roots and perfect squares. So you're going to have to think about this question. Calculate a number that when you take the square root, you get 3 over 8. Let's try an easier number first. What number, when I take the square root, gives me 6? What number that when I take its square root, I get an answer of 6? Square root of what is going to give me 6? 36. How can you figure that out? Just go 6 times 6. What number, when I take the square root, I get an answer of 9?
No.
81, 9 times 9. So follow that pattern. What number, when I take the square root, do I get 3/8? Is it? Exactly. You take 3/8 and times it by itself. And you get 9/64. Okay? And you follow that pattern with the next one. Doesn't matter if it's a fraction or a decimal, you still do it the same way. How would you figure out the number?
Multiply by itself.
1.8 times itself.
Can I say the simple?
Yeah,
6.24.
3.24. Thank you. So you got to be careful how you read some of these. Yes, it.
How would you get the 3?
It's a 3 where?
3.24.
1.8 times 1.8.
Oh, okay.
Yeah. 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 Okay. Next question. Are each of the following numbers perfect squares? Well, basically the test whether it's a perfect square is can you take the square root of a number and get an answer? Okay. So if I look at 9, we'll do this one together. Is 9 a perfect square? Yes, because 3 times 3. Is 49 a perfect square? Yes, because 7 times 7. So that means together they still must be a perfect square. So our answer is yes. Because if we actually took the square root of 9/49, we would get 3/7. How about the second one? I can take the square root of 16. What about the square root of 5? No, not get a whole number, can I? So if I can't get a whole number for both, the answer is no, because of this. Now this next one, Sienna, is what you were kind of talking about. If you look at this, can I take the square root of 8 and get a whole number? No. Can I take the square root of 18 and get a whole number? No. But could I do something to this fraction first? To what?
To 4/9.
Is that a perfect square? Yes. So what you had to do first, be careful sometimes, you may have to reduce first. It may not look like one at the start, but if you can reduce it, you might get one that is. So yes, because the square root of 4/9 is 2/3. So fractions can be perfect squares. So can decimals. Here, you might want to sort of use a little bit of estimating and then use your calculator. Can I take the square root of 0.36 and get an answer? What do I get? 0.6. So this is, yes. Because 0.36, the square root of it is 0.6. Try this one though. If you try that on your calculator, you're going to get a really big long one, right? Okay. that number will never end. The decimals will keep going. They'll never repeat. It's like pi, okay? Which means I can't write the square root of 3.6 as a number, as sort of a regular number, regular decimal. So here, my answer would be no. Because if you try to square root it and you get this big long decimal on your calculator, that means you can't get an exact answer. Okay, last one. Oh, what if we throw some negatives in? What do you think this one would be? Negative, and then the square root of 81 over 100. Yeah. Negative 9/10. Because you do the square root first by taking square root of 81, square root of 100, and then you put that negative in front of the answer. And you get negative 9/10. How about the second one? The negative's inside now. Maybe instead of this one, what's that? 9. What's that? But negative 9 times itself gives you positive 81. Right? Try it on your calculator. You get an error. That means you can't do it. There is no number times itself that gives you a negative answer. Right? Like you can't say negative 9 times 9 because those aren't the same numbers. You can't say negative 9 times negative 9. Yeah, they're the same numbers, but that gives you an answer of 81. So you can't do this. You can't do it. Yeah.
And it can't be the same number. It could be negative 9. Mine would be the big.
It's okay. So if the negative's on the outside, you can do it. But if the negative's on the inside and you're taking square root, you can never square root a negative. Never. Yeah.
I was gonna ask, if you are doing this decimal, if 5 if it's a perfect square, if the answer you get isn't like a bunch of numbers, but it's like.
If it stops, it's a perfect. Yes. But if you see it keep going on your calculator and it looks like a whole bunch of, like, you know, if I said, if you tried the square root of 144 on your calculator, you get 12.
So
In that case, yes. And we're going to talk about those types tomorrow. Yes, but good. Okay. So that takes care of that.